Good morning. You can start, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So today we will see how to find what is the error correction capability of your convolutional code and error detection capability. Error correction and detection capability. So in block code, what we used to find is we used to find the minimum Hamming distance. From the minimum Hamming distance, error detection is d minimum minus 1. Error correction will be d minimum minus 1 divided by 2, the highest integer. We have seen this one. So in convolutional code, to find this error detection and correction capability, we introduced a new parameter, that is d free. Instead of d minimum, here they are using the parameters d free. So once you compute the d free, then error correction, that is error detection will be, error detection capability will be d free minus 1, and error correction capability will be d free minus 1 divided by 2 integer. Okay. So how to compute this d free? For that, they have introduced one new parameters, that is weight enumerating function. A new functions they are defining, that is weight enumerating function is nothing but t of x is equal to sum of ai into x power I, where the summation variable with respect to the I. What is ai? Ai represents the number of code. Okay, the number of code word, you can say the number of code word in a code having a weight I, right? So for example, you have a code word, simply I am writing, okay. So for example, 4-bit. Okay, these are the code word example. Okay, if you take like this way, what is the weight of the code is 2. Here it is 3. Here it is 3. Here it is 1. Then weight enumerating function is defined for this code is t of x is equal to, okay, I is starting from here 1. So number of code word having weight 1 is, having weight 1 is, only 1 is there. So it is 1 into x power 1 plus weight 2, only one function is there. So ai, a2 is nothing but 1, a1 will be equal to 1, and a3, the number of code word having weight 3 will be 2, right? So it is x square plus 2x cube. So in this way we will be defining the weight enumerating function of your code. So for convolutional code, how to find this weight enumerating function? This weight enumerating function can be defined using the Mason gain formula. Okay, it is defined t of x, we can define using Mason gain formula. I think you have studied in the control system. Okay, so how this Mason gain formula is defined? So t of x is given as sum of forward gain into delta I divided by delta. This you have studied, right?
Yes, ma'am.
Okay. So Fi is what? Path gain of the forward path, ith forward path. Delta I is the part of the graph not touching the ith forward path. Okay. This one is the part of the graph not touching the ith forward path. Then how delta is defined? 1 minus sum of your loop gains, right? Sum of your loop gain plus sum of Ci Cj. What is this one? Can anyone tell me? How will you define this one? This is gain of the loop. Okay, how many loops are there in the function? Based on that, you take the gain of all the loops and add it, you will be getting the sum of Ci. What about this one? Sum of the product of the loop gain of all pair of non-touching loop. Sum of the product of the loop gain of all pair of non-touching loop. Then you will be having next one will be minus of 3 non-touching loop, product of the loop gain of the 3 non-touching loop. Like this way it goes on. Okay, so here we will take a example of this one, 2, 1, 2. So we have a state diagram and we draw a state diagram for this with the help of the state diagram. Next one, we are going to modify this state diagram. Based on that, we can find out the Mason gain formula. So here the initial 4 states are there: S0, S1, S2, S0. Initial and final stage, we are breaking it as the starting and ending. Here it is S3. Okay, 4 state S0, I am dividing with the initial and final one. So here if you take S0 to S1, the number of ones present here is 2. So we will be writing x power of what is the Hamming weight of this code. So here output or Hamming weight of this output. So Hamming weight of the output is 2. So x square. So from S0 to S1, arrow mark is important, it is S square. Next one is what? S1 to S3. S1 to S3, it is X. S1 to S3, X. Next one, S3 to S2, it is X. Here it is X. Similar way, S1 to here, S1 to S2, X. So S1 to S2, S1 to S2, it is X. Next one is S2 to S0, it is X square. S2 to S0 is X square. S2 to S1 is 0, x power 0, that is 1. Here S2 to it is 1. Last one is S3. S3 to S3 itself, it is X. So here it is X. Okay. So this is the modified state diagram. So first from here we will find out what are the loops are there. How many loops are there?
Ma'am, S0 to S0.
S0 to S0 we are breaking, right? Initial and starting, final one.
Okay, ma'am.
Okay. Now you tell me how many loops are there? First loop is S3 to S3. Okay, what is the gain of that loop? X. Okay, second one, this loop we can consider S1, S2, S1. So what is the gain of this one? Here this forward path is X. From here to here it is 1. 1 into X, X. Third loop is This one we can consider S1, S3, S2, again S1. S3, S2, again S1. If you take, so from here to here X, here it is X, so X square. Then from here to here it is 1. So here is loop gain is X square. Okay. So next one is two non-touching loop. Pair of a non-touching loop. Non-touching loop. So if you take these two loops, the state is not repeating. These two are non-touching. So for that gain is X into X, X square. So only one is there. So that we can write it as this one as the loop 1. This is loop 2. This one is loop 3. So C1 and C2 are non-touching loop. So the corresponding gain is X square. Rest of the things, if you take one, C1 and C3, S3 is common. So it is touching. Then C3 and C2, if you see S1 and S2 are there common. So it is touching. So only one pair of non-touching. 3 pair it is not there. So it means we can write from here delta value is 1 minus sum of these loop. So X plus X square. Next one is plus pair of non-touching one, only X square is there. So from here if you take X square will be getting cancelled. It is delta is 1 minus 2x. Okay. So next one is we have to find out what is forward path. Forward path gain we have to find out. So now you tell me what is the forward path?
S0,
S0, S1,
S2,
S2, S0. That is one direct. So it is X square. This line is X square.
X per 5.
Okay. So here this one we can take one forward path. What is the next forward path? From here, 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 here. Okay. Second. What else is there? Only two, right? One is this one, another is this one. Only two forward paths are there. So first forward path is S0, S1, S2, S0. The corresponding path gain is X power 5. Next one is we have taken S0, S1, S3, S2, S0. So it is X square into X, X cube, X power 4, X power 5 and 6, X power 6. Correct? So next one is we have to find out what is the one? Delta 1. So two forward path means you can write I is equal to 1 to 2 Fi delta I divided by delta. So what is delta 1? So this forward path should not touch the
ith
loop, right? So S0, S1, S2 is there. So it means it is not touching this one. First C1. Correct? Forward path is not touching the first forward path is not touching the your C1. C1 is S3, S3. So del 1 is nothing but we have to write 1 minus of forward path, that is X. Okay, what is delta 2? Delta 2 S0, S1, S3, S2, S0. All the states are coming here. So it means it will be touching all the loops. Okay, any loop if you take, it will be touching it. So it means the corresponding delta 2 value is 1. So from here T of X value will be X power 5 into 1 minus X plus X power 6 into 1 divided by your delta value. We have computed it as 1 minus 2x. Okay. So from here we can find out that t of x is, so here x power 6, it will be getting cancelled. So it is x power 5 divided by 1 minus 2x. So we will do this one as the log division. So it is 1 minus 2x, x power 5. So first we are multiplying it by x power 5. So we will be getting minus twice of x power 6, ordinary one. Okay. So here it is minus plus. So it is 2x power 6. So 2x power 6. So here it is 2x power 6 minus 4x power 7. Like this way it goes on. So we will compute till 3. Okay. So t of x can be written as x power 5 plus 2x power 6 plus 4 into x power 7. Like this way it goes on. So from here if you take t of x, it is a weight enumerating function, right? So we have know the formula, that is t of x should be equal to sum of ai into xi. What is ai? Number of code word in a code having a weight I. So by seeing this t of x here, it starts with the power of x power 5. It means the minimum weight of a code word will be x, that is 5. So how many number of code word is having the weight 5? 1. How many number of code word is having weight 6? 2. So it means the minimum weight of a code, minimum weight of the code word for a 2, 1, 2 convolution code is 5. So this we are calling it as D free. Okay. So if D free is 5, error deduction capability will be D free minus 1. So it is 4. Error correction capability, if you take 4 by 2, it is 2. Okay, 4 by 2, it is 2. So in like this way we used to compute the, we will find out the what is the error correction and deduction capability of your code, that is your convolutional code. Is this clear?
Ma'am, like in the example you saw, it was able to correct only 1 bit, but here it is correcting 2.
2 bit. If I see here, I don't know whether what mistake I did. Have you computed this one? Yesterday, have you checked, cross-checked whether the first graph, whatever I made, is correct or not?
Ma'am, there was a small mistake in this taking 0, 0. And after that, like everything else was a mistake. Like in the second one. This
Second one. What about the first one?
First one is a 2-bit error, so we couldn't completely get the right one. We said that it will be able to correct only 1-bit error.
1-bit error. So we took the same one, right? S0, S1, S2, S3.
Yes, ma'am. Only
Yes.
with different received vector.
Yes, yes. So can you just cross check once again with this one? Okay. You introduce a 2-bit error and 1-bit error. Please check whether it is able to correct 2-bit and 1-bit. 3-bit also you can give and try to see whether it is able to correct or not. If you are not getting it, you please tell me. 2-bit, because I don't know whether I did the computation properly or not. Okay, you please cross check. If you are not getting it, you please message up. I will work it out this one and I will show the output, that is a trellis diagram 1 to you. Okay.
Okay, ma'am.
Okay, ma'am. So for your exam final one, your portion is both linear block code and convolutional code. So if you have any doubts, you can ask me. So what is the weightage for the final exam for this error control coding? You please ask Suraj sir. Okay, he is the one person deciding how much mark to be given for error control and all. So any doubt? Convolutional code, you can follow Simon Akins, okay, your communication system by Simon Akins or digital communication by Sklar. These two books is enough to follow this for the convolutional code as well as your linear block code. Okay then, ma. If there is no doubt, then I can wind up this class.